Having a bad day? What could be worse? You could be living in a world where doctors still lobotomize the living Jesus out of your prefrontal cortex to ward off Satan, or even go through a 14-hour surgery without anesthetics. Well, Johnny, looks like you got situs inversus. Your organs are flipped over left, right. Gee, doc, what am I going to do now? Well, I'd hate to be the guy with the inverse testicular sacs, so I ought to do some surgery on this thing. Well, thankfully, us 21st century folk don't have to worry about any of that. Instead, the video today is about xenotransplantation, a process in which the organs or tissues of an animal are transplanted into humans. Its initial intended purpose was to serve as a way for critical condition people to receive a transplanted organ, whom otherwise would be held back from receiving a human one due to the almighty transplant list. And with that came the first scientifically organized xenotransplant in the United States, 1963, in which 6 patients were given transplants of baboon kidneys. For an experiment that was very trial and error oriented, as well as the fact of the scientists not having much knowledge about the possible outcomes, other than the nebulous results of the dog bone transplant, it was seen to have gone somewhat well, with the patient surviving a total of 98 days. Wow, nice, and not so nice. Obviously, it was unfortunate to not have those people live to see the light of another day, but at the same time, it was seen as a foot in the door, with many more opportunities to come. A more recent case of a xenotransplant occurring happened in 1993, where baboon bone marrow and kidneys were given to a patient. An attempt of administering a mixture of immunosuppressive drugs were used to ease and help the transplant, but the resulting shutdown of the immune system concluded in an infection that killed off the patient in 26 days. But let's cut all that, and quickly jump into the logistics of it. For a quick recap, xenotransplantation works by having an animal's tissue or organ put inside a person. And to be more specific, xenotransplantation is separated into 2 main classes. Number 1, solid organ xenotransplantation, in which a major organ is transplanted from an animal to a person. Think hearts, kidneys, or livers. Number 2, cellular and tissue xenotransplantation, the insertion of tissues or cells, for example, the heart valve of a pig, into a person, excluding the surgical link of the animal blood vessels to the recipient's blood vessel. For xenotransplantation, the desired and agreed upon animal for transplant use is the pig, rather than other animals like primates, because the organs tend to be too small and too inefficient to maintain the needs of the average human, while the organs of a pig are like a perfectly mirrored version of our own. With all this being said, the process of xenotransplantation brings about a few major issues. Issues with transplanting a different species organ into a human body is that the body's immune system will recognize it as a foreign object, not a part of the human body. That's why the previously mentioned cases of the baboon kidney and bone marrow transplant did not go as planned. As in the first example, there was no proper medicine used to stop the immune system from attacking the new organ tissue, while the second case involved the total and complete shutdown of the immune system from the drugs they used. In fact, the immune system, more specifically human leukocyte antigen, HLA, specifically looks for and identifies the things that the body does not produce, like the antigen produced from pigs, galactose polysaccharide, or alpha-gal. Side effects of HLA finding out can include blood clots, organ failure, and ultimately, organ rejection. There's just so many types of HLA, and it's just so diverse. So that in turn is what makes it that much harder for the donor HLA to match with the recipient's HLA. So how do we avoid this problem? In order to avoid the immune system problem, one can preserve the material without all the old cells by using a preservative liquid called glutaraldehyde. The caveat with this one though is that all the cells are technically dead from the glutaraldehyde procedure, and in turn wear out over time, as there are no cells to replenish the old ones. Think of it as if you were a retail worker working long shift hours with no one to relieve you. You'd burn out eventually. What's worse is that there's still some antigens left on the tissue after this procedure, which still somehow manage to trigger the body's immune response. This is especially prevalent with people who have strong immune systems. The result, the valve eventually wears out. To minimize the tyrannical chaos that the antigens bring about, scientists identify the main antigen that the human immune system likes to attack in pig tissue, galactose polysaccharide, or alpha-gal, and just decided, screw it. Why not just genetically modify the pigs to not express the gene in the first place, so that the human body would just accept the pig organs more readily? And that's what they did. Unlike other practices, xenotransplantation is not outlawed or in such a gray area. Canadian law currently permits xenotransplantation so long as you get the thumbs up from Health Canada. And what's better is that when it comes to tissue like pig valves, they aren't counted as xenotransplant material as they are chemically treated before use. To date, no applications have been received or approved in Canada, and thus no procedures have taken place. The last thing to consider for xenotransplantation would be ethics. The technology is just not developed enough. It's only produced a few successful results, with even those lasting from a few weeks to a few years. Would it be right to change the genetics of innocent animals for the sake of our selfish desires? Or even just take their organs and harm them? Additionally, some people just don't feel comfortable with having animal parts inside them. Just the mere thought of an animal that has historically been seen or used as a standard for dirtiness might seem disgusting to them. But even with that aside, the technology for doing this procedure and maintaining it afterwards would only be available for the upper 1%, and not just any average person due to how expensive it is. Personally, I think it's a work in the progress. Without sacrifice, there can bear no change. And the process of xenotransplantation is just one of the many procedures that are essential to the advancement of modern medicine. There's just so much left to be discovered in terms of organ transplantation. In fact, most if not all the medicine and modern technology we have today came from the process of experimentation. Without it, who knows what kind of medicine we probably would have had today. Nonetheless, I hope I was able to give you some insight into xenotransplantation as a practice, and I hope you find a way to put your hand in science that can save the futures of many.